In this example, we're given a conjugated diene and we're reacting it with HBr, but we're considering two different reactions and we want to figure out the products of each. So what are the products if we react this starting material with HBr at 40 degrees Celsius, so a higher temperature, versus what are the products if we react the same starting material at a low temperature, minus 78 degrees. So we want to figure out what we're going to get under each set of circumstances. The way we tackle this problem is essentially the same for both sets of conditions. It's just at the end in how we determine the products that are going to result. So in this case, you have an unsymmetric diene. That means it's going to be a little bit more work, but let's number the carbons in our diene, and we can number starting here, 1, 2, 3, and 4. But if we draw this same diene again, we also have a different numbering scheme, 1, 2, 3, and 4. And we need to consider both of these when we draw out the products. So what we want to do is figure out all of the possible products that we can get. Now you can certainly go through the mechanism for this, and I encourage you to do that, but if we're just predicting the products, here's how we can do this. So we want to draw the 1,2 product from this first substrate, and to do that, all we need to do is add the hydrogen to carbon 1, the Br to carbon 2. And we want to add the Br next to this other double bond because this is where the carbocation would form in the mechanism. So here is one of the 1,2 products. Now for the 1,4 product, again, you can get this through the mechanism, or if you're just predicting the product, all we need to do is we'll draw our main framework. Which is this. For the 1,4 product, the hydrogen will add to carbon 1, so let's number this. The hydrogen will add here. I'm not going to draw it in. The Br will add to carbon 4. And then, because of resonance, the double bond moves between 2 and 3. Okay, so let's label these. Here's a 1,2 product. Here's a 1,4 product. Now let's look at our second numbering scheme and do the same thing. So for the 1,2, the hydrogen will go on carbon 1, the Br on carbon 2. And then for the 1,4, the hydrogen will go on carbon 1, the Br on carbon 4, and the double bond between 2 and 3. Okay, so these are our 4 possible products. So now what we want to do is figure out which products result at which temperature. So the first thing you can do, which is fairly easy, is to identify the kinetic products. The kinetic products are just the 1,2 products. So let's do a couple of things here. Just to help us keep track of our structures. I'm going to give each structure a letter. And then our kinetic products are the 1,2 products. Okay, kinetic control happens at a low temperature. So in that case, we're going to get the kinetic products A and C. So if you do this reaction at minus 78 degrees, the products that you're going to get, you'll get product A and product C. Okay, now let's think about the thermodynamic products. And for thermodynamics, you're looking for the most substituted double bond possible. So here we want to go through and look at the double bonds. And we want to classify them. So in product A, the double bond has 2 carbon groups. That's a di-substituted double bond. In carbon B, or product B, the double bond has 3 carbon groups. That's tri-substituted. In C, it's di-substituted. And in D, it's tri-substituted. So now to figure out what products we're going to get thermodynamically, that's going to be the most substituted double bond products. It could be a 1,2 product, it could be a 1,4 product, or some combination of each. In this case, for thermodynamic, we find that the most substituted double bond we get in the products is a tri-substituted double bond. And that's in product B and in D. So if we're under thermodynamic control, which is what we have at higher temperatures, we get the thermodynamic products. And in this case, that's going to be products B and D. Okay, now in this particular example, the 1,4 products ended up being the thermodynamic products. But that doesn't always have to be the case. It is very possible that you could get a 1,2 product as a thermodynamic product and not a 1,4 product. So don't think about 1,2 and 1,4 for thermodynamic products. Kinetic, it's easy. The kinetic products are just the 1,2 products. Thermodynamic, look at the double bond and pick the ones that are the most substituted.